Hello everyone, my name is Dan the Tutor. Today we are going to be looking at a bunch of quadratic formula problems. In other words, these are problems that are going to have an x squared in it somewhere in the problem. And we're going to talk about the three ways of solving quadratic equations. 1, factoring, 2, quadratic formula, and 3, taking the square root of both sides. Now each one has a specific purpose and time when you should use it, and so I'm going to be giving some insight into when each version is the best method to solve. Like if you're making a house, you don't always want to use the hammer. Sometimes you need the screwdriver, sometimes you need the saw. There's a bunch of different tools we have in our toolkit, and we need to know not just how to use all three, but when to use all three, more importantly. So the first question I have here is 12x squared plus 24x equals 0. So the way I would solve this one is noticing the fact that both of the terms have x in them. Whenever that happens, that means that we can factor out the x as our first step, and what's left in the parentheses, well, if I take an x out of 12x squared, I still have 12x, and if I take an x out of 24x, I'm left with plus 24. I then set this equal to 0, and the trick here is that I can set both of these terms equal to 0. So that means x equals 0, and 12x plus 24 equals 0. So now, once I get this far, I immediately have the solution x equals 0, and now I just have to solve the other one for x. To do that, I'm going to subtract 24 from both sides. So 12x equals negative 24, and then just divide both sides by 12. X is going to equal negative 2. That's going to be my second solution. So I have two solutions to this one, x equals 0 and x equals negative 2. And again, the strategy was factor out the x as my first step. Notice I won't be able to do that if I have literally anything else at the end there. So for instance, if I have 12x squared plus 24x plus 3 or whatever, now I can no longer use that strategy because the 3 does not have an x in it. Okay, next problem. X minus 2 squared equals 49. So to solve this quadratic function, the best thing to do is to take the square root of both sides as my first step. And remember, whenever you do take the square root of both sides, make sure you're writing the plus or minus there. Super important. So that means on the left, the square root and the squared cancel out, which is why the strategy works so well. And on the right, we're going to have plus or minus the square root of 49, which is 7. Now here's the part that you need to remember. This part's important. You cannot have plus or minus in an equation. In other words, we need to write this out twice. First, I have x minus 2 equals 7. Then I have x minus 2 equals negative 7. I'm writing the equation twice, one for the positive version, one for the negative version. And then all I need to do is solve both. So for this one, add 2 to both sides. I get x equals 9. And for the right one, I will add 2 to both sides as well. And I get x equals negative 5. And there's my two solutions for that one. So the next problem I have, it's a word problem. Let's say I have an advertisement billboard. And I'm going to tell you that its length is 6 feet longer than its height. So whatever this length is, whatever this height is, this length is 6 feet higher or longer, whatever you want to say. I also know that the total area here in the middle is 352 feet squared. So I have the total area, and I have this fact that the length is 6 feet higher. And the goal is I want to find L, the length, and H, the height. And the secret to this one is the fact that this is going to be a system of equations. I have two equations here to go off of. The first equation is the fact that the length is 6 feet longer than the height. How do I represent that? I'm going to say L is equal to H plus 6. A lot of people will mistakenly say, hey Dan, shouldn't it be the other way around? Shouldn't it be L plus 6 equals H? And this is going to be wrong, and let me prove it really fast. Let's just make up numbers, for instance, and we'll prove that this is right. Let's just say, hypothetically, the height is 10, and I want to therefore solve the length. Well, if the height's 10, 10 plus 6 is 16, so L is 16. Using this equation, this confirms the length is 6 feet longer, which is what we want. And if I have it the other way around, it's going to be shorter, so that's not good. So again, I made up those numbers. I'm just going to erase them because I don't want to cause any confusion. So this is the first equation I have, L equals H plus 6. And the second equation has to do with area, the area equation. And that's literally just going to be the area of a rectangle, which hopefully we all know from first grade, maybe fourth grade. But the area is going to equal the length times the height. Now all we need to do, this is where Algebra 2 comes in, which is usually a 10th grade topic. The secret is that we're going to plug in this length right there. And to do that, we now have the area, which I know is 352, is equal to the length, which I'm saying is quantity h plus 6 times h. And so now what I cannot do, I cannot set h plus 6 and h equal to 0 or 352 like we did in the last one, because it doesn't equal 0 right now. It equals 352. And you can only use that strategy of, for instance, this, I'm just going to tell you this is illegal. Do not do this, but I'm just showing you because maybe you think this based on the last problem we did. Again, this does not work because you can only do that strategy, set each equal to the left side, if it's equal to 0. Since it's not equal to 0, there's only one thing we can do here, and that's start to simplify. And the way we're going to simplify this is distributing the h to both terms. The left side I'm not touching, it's 352. On the right side, I have h squared plus 6h. Now, this is still not great. I need to move over the 352 to the other side, so it's equal to 0. And when we do that, I get 0 equals h squared plus 6h minus 352. And now you can probably factor this. However, this seems a little ridiculous to find the factors of 352. So instead, I'm just going to use the quadratic formula, which is what I would probably do on a test anyway, where a is 1 because there's a 1 in front of the h squared, an invisible 1. B is going to be 6, and C is going to be negative 352. And all I need to do is plug in the quadratic formula, which is going to say h equals negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a times c, so 4 times 1 times negative 352, all divided by 2 times a, or 2 times 1. And now let me plug this in a calculator real quick and see what we get for the square root. Okay, so it turns out this is a perfect square. When you plug this all under the square root, you get negative 6 plus or minus 38 over 2. Again, I just plugged all this in my calculator and I got 38 there. And now the trick here, once again, since we have a plus or minus, I need to write it out twice. I need to say negative 6 plus 38 over 2 and negative 6 minus 38 over 2. And I'm going to get two solutions here. The first solution I'm going to get is 38 minus 6 is 32, 32 over 2, so I get 16. The other solution is going to be negative 44 over 2, so negative 22. Now I can't have two answers for my height. There can only be one height in this problem. And I'm going to tell you it cannot be the negative because you cannot have a negative height in real life. So the height's going to be 16 feet. And if I want to find the length, remember the length was just the height plus 6. So the length is going to be 16 plus 6. The length is 22 feet. So there's my length and there's my height. Okay, for this next one we have another word problem. Imagine that we're building a pool with a little walkway deck around it. Okay, so in the middle we have the pool, and on the outside we have the deck. Now the dimensions of the pool are going to be 40 feet long by 30 feet wide. And on the outside, this deck is surrounded by a length x. In other words, every dimension around the deck is going to be x. Now we know the total area surrounding the entire thing is 2,576 feet squared. And what we want to know is the length of x in order for all of this to be possible. So what we need to do for this problem is we need to come up with an area formula that will find the total area of the outer rectangle in white, which would also include the rectangle in the middle, the blue. And the way we would do that, it's actually not terrible. We're going to say that the total area is equal to 2,576, which we know. So now the total length and width of the pool, the total length is going to be this distance right here, which we know is 40 plus x, because that's going to give you the whole length of the pool. X plus 40 plus x, in other words, 40 plus 2x. And again, that's going to be my length, because at the end of the day, area is going to equal length times width, or length times height, where this is the length and this is my width right here. To find the width, we're going to do the exact same thing, where the width is going to be 30 plus x plus another x. It's going to be 30 plus 2x. That's my width. And so now we have one equation, one unknown. We can now solve for x. Not super easy because this is a big number, but we can do it. And the way we're going to do that is we need to FOIL. So when I FOIL this, 40 times 30, that's going to be 1200. 40 times 2x is going to be 80x. 2x times 30 is going to be 60x. And then 2x times 2x is 4x squared. On the left side, I still have 2,576. Now on the right side, I'm just going to simplify it. So 2,576 equals 4x squared plus these two combined to make 140x, and then plus 1200. And now if I want to solve for x, I need to set it equal to 0, which means I'm subtracting 2,576 from both sides. That's going to give me 0 equals 4x squared plus 140x minus 1,224. And now that I have this, all I need to do is plug into a quadratic formula once again, where a equals 4, b equals 140, and c equals negative 1,224. So that means that my x is going to be negative b, so negative 140, plus or minus the square root of b squared, 140 squared, minus 4 times a times c, using all the numbers there, all divided by 2a. So that's going to be divided by 2 times 4. Once again, let me plug in the part in the square root in my calculator. And that is not going to be a whole number, which is fine. But we're going to get negative 140 plus or minus 198 divided by 8. And once again, what I need to do here, I need to split apart this into two different functions. X equals negative 140 plus 198 over 8. And then x equals negative 140 minus 198 over 8. And let's see what I get when I plug both of these in my calculator. So for the first one, I get x equals 7.24. And for the second one, I get negative 42.2. Once again, this deck cannot have a negative distance, which means the negative one is out. And the answer is going to be 7.24 feet. Here's the next problem. It's actually more like a physics problem, but it works for math as well. So let's say I drop a rock from the top of a bridge, and it is going to land on the bottom, and that distance to the bottom is, let's say, 1,045 feet. Now, if this were a physics problem, I wouldn't give you the following equation, but since this is a math course, I'm going to give you the equation for the position of this rock. And the position, we'll call it S, is going to be equal to negative 16 t squared plus v naught times t plus s naught. So it doesn't say what v naught and s naught are, but I will tell you. V naught is the initial velocity, which we're going to assume is 0 because we're going to drop it from rest. That's why that's 0. And then SO is the initial position, which is that 1,045 number. So that's going to equal 1,045. So at the end of the day, we have the position S equals negative 16t squared plus 1,045. That's half the battle right there, just figuring out this equation. The second part is actually finding when it hits the ground. And when it hits the ground, that's saying that the final position, S, is 0. So in other words, 0 equals negative 16t squared plus 1,045. Now once again, we have three strategies for solving this one. One is factoring, one is quadratic formula, and the other is solving using a square root. We're going to solve this using a square root, but first we are going to add 16t squared to the other side, like so. When we do that, we get 16t squared equals 1045, and then we can even divide both sides by 16. So now we have t squared equals 1045 divided by 16. Now the reason why the square root method works here is because once you just have t squared equals, this is the perfect time to take the square root of both sides, and it's plus or minus. Because whenever you take the square root, it's plus or minus. Now let's plug this in our calculator and see what we get. We'll get a final answer of t equals 8.08. Technically plus or minus 8.08 seconds, but of course we're going to cancel out the negative answer once again because we cannot have a negative time in this real world problem. Or else, if there was no real world context, then we could accept both answers. So the next problem we have is, let's imagine that we have an owl chasing a mouse directly below it. I am not good at pictures, so here's my owl and here's my mouse. And it's going to be darting towards the mouse to try and catch it and eat it. Now once again we're going to say it starts from rest. This time we'll say the initial distance between the two is 144 feet. And we're going to use this equation, s equals negative 16t squared plus v naught t plus s naught. And the question becomes, how long will it take for the owl to reach the mouse? Well, once again, to do this, the fact that it's at rest means that v naught is 0 and s naught is going to equal 144. Also the same as last time, that final position s, that's going to be 0 because we're counting 0 as the ground. Maybe I didn't explain it the best in the last one, but nonetheless, I can say it now. So 0 equals negative 16t squared plus 144. Again, it's the exact same thing. Add 16 squared to both sides. So we get 16t squared equals 144. Then divide both sides by 16. T squared is going to equal 144 over 16. And then again, we take the square root, and it's going to be the plus or minus the square root because you're taking the square root of both sides. So we get t equals, we actually do know this pretty simply. The square root of 144 is 12, and the square root of 16 is 4. This is, again, plus or minus, but we're going to ignore the minus because you can't have a negative time. And finally, this just reduces to 3 seconds. And it's going to take 3 seconds for this owl to reach this mouse. So now we're going to take a change of pace from the last couple word problems, and we're going to talk about the discriminant. So the discriminant, one of the more odd vocabulary words in all of algebra, it's something we're going to use to find the number of real or imaginary solutions in the problem. And where the discriminant comes from, if I remember quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, the discriminant is just b squared minus 4ac. Not even the square root. So the discriminant is b squared minus 4ac. And we're going to get 3 potential answers from this. We're either going to say b squared minus 4ac is greater than 0. In other words, it's positive. If that's the case, you're going to have 2 real solutions. If b squared minus 4ac equals 0, then we're going to have 1 real solution. And then if we have b squared minus 4ac is less than 0, in other words it's negative, this is when we get 2 imaginary solutions. And in case you're curious where this comes from, this just comes from the fact that if you have a square root, then a positive square root is 2 real solutions. If you get 0, it's not impossible. It just means that the square root part goes away, and the only solution then you have is negative b over 2a. That's why it's 1 real solution, negative b over 2a. And then for the 2 imaginary solutions, that's because if you get a negative square root, that's an imaginary number. So that's where that comes from. So for this first problem here, let's say that we have x squared plus 2x plus 6 equals 0. X squared plus 2x plus 6 equals 0. And I want to use the discriminant to find out how many solutions there are here. It's pretty simple. A is 1, B is 2, C is 6, and all I got to do is B squared minus 4AC, which means 2 squared minus 4 times 1 times 6. That's going to equal 4 minus 24, which is negative 20. That's negative, so that means we're going to have 2 imaginary solutions for that one. And it's as simple as that. Now, the only time you have to really be careful with the discriminant is if I give you a problem like this. 48 minus 24x equals negative 3x squared. The reason why you have to be careful here is because this doesn't equal 0. I need it to equal 0 to use quadratic formula and therefore solve for the discriminant. So the easiest thing to do would be to move this 3x squared to the left on both and reorder this so it's in the normal order we're used to seeing for quadratic formula. So in other words, that's going to look like 3x squared minus 24x plus 48. That now equals 0. And now it's in the form we like, and we can easily find A, B, and C. So A is going to be 3, B is going to be negative 24, and C is going to be positive 48. And again, I just have to do B squared minus 4AC. But be careful, because negative 24 squared will be a positive number, because two negatives multiplied together, of course, make a positive. So it's going to be this number squared minus 4 times 3 times 48. And let's plug this in a calculator and see what we get. And would you look at that? We get exactly 0, which means there's one real solution. And that's pretty much all we need to know for the discriminant. So now, enough of the discriminant. Let's actually use the quadratic formula to solve the next couple problems. Let's say I have 9x squared minus 9x plus 2 equals 0. For this one, all I need to do is identify A, B, which is negative 9, and C, and then we can plug in the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now before I do this, I just want to explain real quick why we have to use quadratic formula here. Because again, there's only 3 ways I can solve any of these quadratic functions. The first is factoring. This is not going to factor well because that number 9 right there is not a friendly number to us. We almost certainly need it to be a 1 there, and since it's a 9, that's not going to work out. We can't use the square root method because there's 3 terms. Typically the square root method only works with 2 terms, like if this minus 9x wasn't here at all, then we could do that. So quadratic formula becomes our last resort, and that's fine. So now we just have to plug in x equals double negative makes a positive, so positive 9 plus or minus the square root of negative 9 squared, which again will be a positive number, minus 4 times 9 times 2 all over 2a, so 2 times 9. And just real quick, I'm gonna plug in the part in the square root in my calculator. So when I do that, I end up getting 9 plus or minus 3 over 18. And like we said before, we just have to break this up into 2 different functions. X is going to equal 9 plus 3 over 18, and x is going to equal 9 minus 3 over 18. And yes, it's necessary to do this every time. So it's going to be 12 over 18, which is what the top simplifies to. Actually, that simplifies to 2/3. And the other one is going to be 6 over 18, which reduces to 1/3. So my 2 answers here are going to be 2/3 and 1/3. So now let's do a tricky one. We have quantity x plus 2 squared equals negative 2x. Now this looks like a square root at 1 at first, because we can take the square root of that and the square root of that. The only problem is, and then plus or minus. The only problem with this, if I do this, then I get on the left x plus 2, and on the right plus or minus the square root of negative 2x, and now we can't solve for x because it's stuck under a square root. So this method, you do not want to take the square root because you're going to have a square root of x when you do that. Which then begs the question, what do we do? Well, I'll show you. So again, the problem was x plus 2 quantity squared equals negative 2x. The secret here is instead of taking the square root, this is when we're going to FOIL the x plus 2, which is because it looks like this when you write it out. And then I can FOIL this pretty easily. So it's going to be x squared plus 2x plus another 2x and then plus 4 equals negative 2x. Now if I combine like terms here, on the left side that is, I get x squared plus 4x plus 4 equals negative 2x. And again, I want it to equal 0 because I can't solve this unless it equals 0. So I need to add 2x to both sides. And when I do that, I get x squared plus 6x plus 4 equals 0. Now, here's the problem right now. If I think of the factors of 4, it's 1 and 4 and 2 and 2, and I needed to add up to 6 in the middle, which is just not going to happen because 1 plus 4 is 5 and 2 plus 2 is 4. You're never going to get 6x with factoring, which is fine. That's why we have quadratic formula. But this is literally what it will look like if you ever try and factor and it doesn't work. You're not going to get the middle term no matter which factors you choose. So that means we're using quadratic formula where a is 1, b is 6, and c is 4. So that means it's going to be x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 4, all divided by 2 times 1. Okay? And then this one's actually not too bad at all, at least not yet. Negative 6 plus or minus the square root of 36 minus 16 over 2. And then we can say negative 6 plus or minus the square root of 20 over 2. And the square root of 20, at least its most simplified form, is the square root of 4 times the square root of 5, which means that's equal to 2 root 5. So we're going to get negative 6 plus or minus 2 root 5 over 2. This looks ugly, but it actually comes out to be a nice number. Again, I'm going to rewrite it twice. One says negative 6 plus 2 root 5 over 2. And then negative 6 minus 2 root 5 over 2. And the reason why this is so nice for both of them, both are divisible by 2, the denominator. So in other words, when I divide both numerators by 2, I get negative 3 plus the square root of 5. Again, I did this by canceling out the 2's here, and that would become a 3. And the exact same thing is going to happen here. So it will become negative 3 minus root 5. And again, I did that because whenever I have the 2 in the denominator and both of these numbers are divisible by 2, I can cancel them out, leaving me with the answer we see right here. And now we have another trick question coming up. X squared minus 2x plus 6 equals x squared minus 6. The reason I say this is a trick question is because the first step is to have it equal 0. So I'm going to subtract x squared from both sides, and I'm going to add 6 to both sides. And when I do that, I get 0x squared minus 2x plus 12 equals 0. Now if I have 0x squared, I'm just not writing the x squared. It goes away. So in other words, negative 2x plus 12 equals 0. This isn't even a quadratic function. This is now linear, which means I can easily add 2x to both sides. So 12 equals 2x, and x is going to equal 6. Again, the secret to all these quadratic equation type problems is you need to get it equal to 0 probably as your first step most of the time. Next, we're going to have another word problem. So we're going to start by giving this equation for the cost of something, whether it be making toasters or manufacturing mattresses, I don't really care. But the cost is going to be 0.5x squared plus 15x plus 3,000. And we want to solve for x, the number of units we must produce, if we want to create a cost of, let's say, $12,500. So we want to know how many x units we can produce for 12,500. So once again, this is just a quadratic formula problem because this is way too hard to factor. But before we do that, we first need to get the left side, this cost, to equal 0. So let me just rewrite it real quick. 12,500 equals 0.5x squared plus 15x plus 3,000. First thing I do, subtract 12,500 from both sides. Now we have 0 equals 0.5x squared plus 15x minus 9,500. And then once again, we're just going to use the quadratic formula where a equals 0.5, b equals 15, and c equals negative 9,500. So plugging in the equation, we've got x equals negative b, negative 15, plus or minus the square root of b squared, 15 squared, minus 4 times a, 0.5, times c, negative 9,500, all divided by 2a, so 2 times 0.5. Let's see what I get for the square root when I plug that in a calculator. So we don't get a round number, but that's okay. We're going to get x equals negative 15 plus or minus 138.7, all divided by 2 times 0.5 is actually just 1, which means you don't even have to write divided by 1. And once again, I'm going to split it up into the plus and minus version. So the first version is negative 15 plus 138.7, and the other solution will be x equals negative 15 minus 138.7. And at this point, it's just simple addition. The first one's going to be 118.7. I think that's right. No, it's not. 123.7. 123.7. And our other solution will be x equals negative 153.7. And that one's impossible because you can't produce a negative number of units. So if we want to know rounded to the nearest whole number, because you can't make 0.7 toasters, it's, you know, you can only have a whole number of units you're producing, we'll say a final answer of 124 units that we want to produce. And now we have the last problem I have to share with you today. It has to do with revenue and demand, kind of some economics terms. Typically, you would actually see this kind of question in a business calculus class, but we're going to make it a pre-calculus question, which is fine. So first, I'm going to give the demand function. This is called demand. Its variable is p, and it's equal to, let's say, 55 minus 0.0005x, where x is the number of units we're producing of toasters or mattresses or whatever it is. Now, in general, revenue, which I'm also providing for this problem, is equal to x times p. This same demand function right here is p right there. And if you want to find the revenue, how much money you're making, you multiply the number of units by the demand. In other words, if I were to multiply this out together, it would be x times the quantity, 55 minus 0.0005x, and then we can solve for that or simplify it in the next step. But one final piece of information I'm giving for this problem is I want to know how many units to produce, in other words, solve for x, if my revenue, R, is equal to $210,000. Okay, so that's going to be essentially the left side of this equation from now on. The right side we can distribute to simplify it, and for that we would get, on the left we still have 210,000. On the right we're going to have 55x minus 0.0005x squared. Once again, we're definitely going to need quadratic formula here, but first we need to set this equal to 0. So I'm going to subtract 210,000 from both sides, and I'm also going to skip a step and just write it in the order we're used to seeing it. In other words, I'm going to say 0 equals, put the x squared first, negative 0.0005x squared plus 55x minus 210,000. And now I have my a, b, and c. A is negative 0.0005, b is positive 55, and c is negative 210,000, which is a really big number. So once again, we're going to plug in our formula, and we're going to say x equals negative 55 plus or minus the square root of 55 squared minus 4 times a is negative 0.0005 and c is negative 210,000. All divided by 2a, so 2 times negative 0.0005. Once again, we need to plug this in our calculator and see what we get for the square root portion. And for this, we're going to get negative 55 plus or minus 51.0, all divided by negative 0.001. Okay. Once again, we're going to break this up into two different functions. First, we have x equals negative 55 plus 51.0 over negative 0.001. And then we have x equals negative 55 minus 51.0 over negative 0.001. This is probably too difficult to do in my head, so let me plug it in a calculator. So one answer we get is x equals 4,000, and the other answer we get is 106,000. Which then begs the question, which answer is right? And I'm going to tell you that both of these answers are possible. Why? Because it's possible to produce 4,000 toasters, and it's also to produce 100,000 toasters. So both answers are right because both answers are positive. So thank you all for watching today. I hope you got a much better understanding on how quadratic formula and how we deal with quadratic equations in general. My name's Dan the Tutor, and I'll see you all in the next video. Bye-bye.